Just say start when I have to start.
Yes, you can.
Okay, welcome everyone. I welcome you all to this 15th Women in Science event, which is being organized by Women in Science, Punjab University, in collaboration with INYAS and also the ACS International Chapter of CSIO. So today is a special day. It is February 11. It is the International Day of Women and Girls in Science. So we are happy that we are celebrating it. And we have a couple of research scholars, 5 research scholars who are going to present their work today. And the main theme is full and equal access and participation for women and girls in science. As we all know, a significant gender gap has persisted throughout the STEM disciplines, and even though women have made tremendous progress towards increasing their participation in higher education, they are still underrepresented in these fields. And in fact, gender equality has always been a core issue of the United Nations, and gender equality and empowerment of women and girls will make a crucial contribution not only to economic development of the world, but to progress across all the goals and targets of the 2030 Agenda for Sustainable Development. And in order to achieve full and equal access to and participation in science for women and girls, and further achieve gender equality and the empowerment of women and girls, the United Nations General Assembly had declared 11th February as the International Day of Women and Girls in Science in 2015. And recognizing the role of women and girls in science, not only as beneficiaries, but also as the agents of change, including in view of accelerating progress towards the achievement of SDG 6, which is clean water and sanitation. The 7th International Day of Women and Girls in Science Assembly, which is today, 7th International Day, will focus on the topic equity, diversity, and inclusion, water unites us. So on this day, we are very happy that we have someone, Professor Kia Dharamveer with us, who is our guest of honor. So I'll give a brief introduction about Professor Kia Dharamveer. She is a superannuated faculty member from Punjab University's Physics Department, and her teaching experience spans about 37 years. She graduated from Allahabad University and went on to do Masters MSc Physics from IIT Kanpur, where she also completed PhD with specialization in condensed matter solid state theory. At Punjab University, she has been a coordinator for the Nanoscience and Nanotechnology program, and her research interests and contributions include a wide variety of topics, which include theoretical, computational, and experimental approaches to a number of areas of current interest in condensed matter physics and nanomaterials. Her research works were carried out at IIT Kanpur, Imperial College London, and Punjab University, Chandigarh. Being a socially conscious scientist, she has happily undertaken a good amount of organizational and administrative work, and her current interest mainly lies in popularization of science through her NGO, which is SPSTI, which we all INYAS members know very well because we work hand in hand with them, and we are thankful to them for that. SPSTI is the Society for Promotion of Science and Technology in India, of which she is the General Secretary. The society holds many events throughout the year for students, public, and members. It now has a handsome amount of grant from the DST, Government of India, for running their mobile science laboratory called the Circus of Science. In fact, during the pandemic, the society held numerous webinars on topics of current relevance, and gradually these regional science academies came on board, and presently the seminars are held in association with Chandigarh chapters of NASI, INYAS, and INSA, as well as Haryana and Chandigarh State Councils of Science and Technology. So she is doing and she has done a great amount of work, not only in the field of science, but also for science outreach. And she's very much concerned about the involvement or the contribution of women and girls in science. So I now welcome Professor Kia Dharamveer to please say a few words about this important event, this day, February 11, and also if she wants to share something with all of us. Ma'am, please.
Thank you very much, Nishima. Let me begin with thanking INYAS and the Women in Science group in Punjab University. Thank you for having me here today. I am very happy that you are holding this event. So congratulations from me and congratulations from SPSTI, your associates in other events. So I'm glad that Dr. Nishima spoke about the UN initiative. As far as I'm concerned, I will confine myself to presenting a very brief analysis of what makes a career in STEM so difficult for an Indian woman, and also for an Indian girl to take up a career in STEM. And if you are not convinced that it is difficult, let us consider some numbers. From various sources, including UN, I gathered that India tops the world in producing female graduates in STEM, but it ranks only 19th in employing them. Looked at in another way, 40% of Indians who graduate in science are women. Science, that includes science, technology, maths, STEM disciplined, also biosciences. But more than half of them drop out of the workforce, with the result that merely 14% of the total scientists, engineers, and technologists in R&D work in India are women, only 14%. The global average for that attribute is 28.5%. And these figures are from National Task Force on Women in Science. Incidentally, as I age, I'm becoming more and more like the student who prepares the night before the exam. So only yesterday I came to know that there have been large number of study groups, workforces, and so on by various government agencies, including the National Science Academies. And these numbers have been taken from there. Now, surprise of surprises, I come from IITs, and when I was studying, I spent a good 8 years, MSc and then PhD in IIT Kanpur. So when I joined, there were less than 6% women in IITs across all disciplines, across all programs. When I left, there were about 9%. For many years afterwards, we heard that there are only 12% girls who are getting admission in BTech. Some time ago, I think sometime in 2014 or something, I was told that now there are 15%, as many as 15% girls doing BTech in IITs. The national average, however, is much better. It is around 35% studying BTech. But there is this figure in 2017 of the total applications to various branches of IITs was 10%. So there must be some reason why these are going down. And we make such a song and dance about ISRO having a large number of women in Mangalyaan mission, in Moon mission, Mars mission, and so on. However, do you know what is the percentage of women in ISRO staff? 8%. Then there is the All India Survey on Higher Education, which says that the only areas where the only programs where women outnumber men are one in MSc. All science branches put together, MScs in sciences today are just about 50% women and 50% men, then that is the way it should be. There is one area, can you guess, where women PhDs outnumbered men? No, it is not biosciences, it is mathematics. So let us hold on to that, let us celebrate that, and let me add here that women in mathematics are not only outnumbering as far as PhD is concerned, but qualitatively also they are doing better. There are a number of international recognitions coming our way. So we congratulate ourselves on that. So much for the numbers. And so what emerges that in Indian STEM, the primary concern is not with the number of women graduates, but with the proportion of those who ultimately land STEM jobs. While it is always nice to have more young women studying STEM, these enlarged numbers should not be looked at as a victory. On the contrary, it should be an alarm bell for us. How many of these women will get STEM jobs? A tiny fraction. Now, what are the problems? To my mind, the problems are of two kinds. One involves attitudes and the other involves infrastructure. So the demand in India, as we are digitally transforming, is for competent employees. And we had better look for those from among us, from within the country. And what better strategy than to involve the growing women's task force into it. Now, women have done some groundbreaking research, but in the STEM areas, they are known to be paid less. In a bid to recruit, retrain, and promote women in STEM areas, the Ministry of Science and Technology has taken a large number of steps. Let me quote. So, when we talk about attitudes, we are talking about not only about discouraging women from joining jobs. We all know that there's a biological clock ticking, and just when you are ready to join the workforce, the urgencies of your personal life very often take precedence. So what is the remedy? Nature will not come forward and say that, okay, I will increase your age for that. We have to do it ourselves. So we have to make we have to give more facilities to our women scientists. Now, I'll quote somebody. I'm sorry, I have not written down the source, but this is about attitudes. So while reasons are multiple, the most important one is mindset, which has been targeting women right from their cradles. This gets a push from academic books.
Dr. Nishima,
I think there is some.
is it
Yeah.
that I am not able to hear?
No.
or-
I think there is some problem at her end
Okay.
because, it has suddenly stopped. I think she'll get back.
Sure.
Must be some internet issue. We
Yeah.
all face it all the time.
Yes.
So there is some internet issue at Professor Kia Dharamvi's end. So I'm sure she'll join back. Yeah, she has logged out and she will be joining back.
Are more people on the live stream, Nishima?
Yes, ma'am.
Okay.
So by the time she joins, I would just like to, maybe Dr. Suman would like to give you a brief outline of the plan that we have. Dr. Suman has a slide to share with all of us.
Yes.
Dr. Suman, if you can share your screen. Thank
Yes.
you. Before she starts, I would like to introduce Dr. Suman also. So she's our new member in the Women in Science series. So I welcome her. She's working at CSIO and I know her from the past many years. She's a very good scientist, and she's very much into the field of outreach as well. And we are very glad that she has joined us and she'll be helping us. Thank you, ma'am. And please begin
Thank
with
you,
your.
Nishima, for considering me in your group, because
Oh, please, ma'am.
it gives an opportunity to meet each other and to have interaction. Just 5 minutes, just 2 minutes I'm sharing.
Good morning, Dr. Suman.
Yeah, good morning, ma'am.
Yes, we can see the slide, ma'am.
Okay. So, good morning, everyone. As continuously we are celebrating this with the keynote introduction or keynote lecture or address by Dr. Kia. So, as a part of this program, we have considered this a new opportunity. We thought of that faculty members are invited at every places. So let's give a chance to younger scholars who get this chance to represent themselves in the scientific community. So in line to this, for today's event, we have 5 speakers today. First is Dr. Rashri, who is senior scientist at Imago and Genter, Mumbai. And this is a healthcare and pharmaceutical based disinfectant manufacturing company. She is also heading as a validation team head of this department. Then next speaker, we have Ms. Poonam Yadav, who is doing a PhD from RCB Faridabad. Third in the line is Ms. Deepika Sharma, who is working as a senior research fellow at Punjab University, Chandigarh. And we have Ms. Neelam Vishwakarma. She is doing her PhD at CSIR, CSIO. And Ms. Anshul is also a PhD scholar, and she is from IIT Indore. So it is wonderful to have with us the young speakers who will be sharing their scientific achievements or towards the society. If we talk about their brief introduction, then we will continue as the speakers come. What are their research interest, and what are their challenges they will be covering in their talks. Thank you. This is the brief outline of the speakers, and once Dr. Kia is back, after that we will start their talks also.
Okay, ma'am.
Okay.
Thank you, ma'am. Thank you. So I think she has not yet joined back. So maybe we can start with Dr. Rasheed Patel.
Correct.
Yeah.
Dr. Rashri?
Just a minute. Professor Arun Grover has joined back.
Yes.
Yeah. Sir, can you hear us? Welcome, sir. Professor Arun Grover, sir. Can you hear us, sir?
Yes, I can hear you.
Okay. Welcome, sir. Thank you, sir. Thank you so much for joining, sir. We are very blessed to have you today here. So please, if you can say a few words about this important event, February 11, and also your experience. Thank you, sir.
Okay, so was there a disruption in between because I lost the connection?
Yes, yes, there was some problem. Professor Kia will also be joining back soon.
She is okay, so she is good.
Yeah.
So I am very happy to join today's event. I was expecting a lot many people at this event than the number that is there.
Sir,
So,
this is usually we have a few members here, and rest of it is on YouTube. So people are watching on YouTube. So only a few members who are going to speak are there on Zoom.
Sorry, Nishima. There was something went wrong with my connection. Should
Okay,
I continue, or would you like to?
Ma'am, Professor Grover was
continue.
saying. Okay, ma'am.
Yeah,
Okay.
please.
Please. You continue, then I'll. You finish your thing, then I'll add something.
Today is the Day of Women, so ma'am, you continue, please.
No, so my theme was first to present the numbers to convince people that there really is a problem, in spite of all the efforts people have been making, in spite of all the efforts that the government has been making. And people have tried to find the reasons for that. Reasons are not very difficult to see. The prime reason is attitudinal, that girls are not very much encouraged to pursue science, especially technology. One branch of science which is accepted, so-called accepted for girls, is the medical and allied branches. And we can learn a lesson from here. Why is it accepted? Because it is traditionally so that women are in healthcare. So if we can create a tradition, if we can create an ecosystem where women are in more into engineering, technology, mathematics, and other branches of science, then gradually the intake in these branches will also improve. So apart from attitudinal effects, there are some practical difficulties which are not so much mentioned in these studies, but which I am adding from my own experience, that in smaller places, in villages, not even so very remote villages, just on the outskirts of Panchkula, you will find places where girls are not able to join science in +1 or +2, or colleges where there is science. Why? Because transport is a problem. Coming and going is a problem. There are places like UP, I mean, maybe one should not say that, but it is common knowledge that the law and order is so bad that people don't allow their girls to venture out a little bit further from their homes. So these are the practical difficulties. The academies have come up with a number of recommendations, but they are more
Probably there is again some technical issue at her end. Dr. Suman, are you able to hear to what Professor Kia is saying?
No, there's a problem.
Kia ma'am, there is some problem. She has logged out. I think there's some genuine internet problem at her end today. Normally that doesn't happen. Her internet is usually very good. Okay. Hanji ma'am. Yes, ma'am. There was some internet problem.
Yeah, can you hear?
Yeah. Now I can hear you. Yes, ma'am. Please go ahead, ma'am.
There's a whole list of remedies or remedial measures suggested by the academies and also by government agencies. There are many schemes, and most of us are aware of that. To this, I will add that since today is the day of girls and women in science, so we need to attract more young girls. Our attention should also be to attract younger girls into science by making life easier for them, by maybe give more scholarships, maybe open more avenues so that they can take up science as a career. And one thing which is also lacking in our society is that the young children, that includes boys also, they are not aware about career openings in science. Like what we hear is कि बच्चा साइंस पढ़ेगा तो या तो डॉक्टर बनेगा या इंजीनियर बनेगा. So we need to tell children again and again, especially girls, and to the parents and guardians of those girls, that there are many, many more career openings in science. So the remedy for the time being is talk to them, talk to them, talk to them, and mentor them. So that is our task. And only when we manage these, then we will be able to break the narrow domestic walls, as Tagore said. Thank you.
Thank you so much, ma'am. Thank you. It was really inspiring to listen from you. And I'm happy that INYAS is working in this direction of telling people what are the avenues, what are the options, career options for science as well. So, Professor Arun Grover, sir, if you can please say a few words about this. Sir, if you can unmute yourself, Professor Arun Grover, sir.
I unmuted, but it again got muted.
now you're audible, sir. Yes, sir.
So I'm very happy to join this event where you have Kea as a guest. Kea is notionally 1 year senior to me as a National Science Student Scholar. So not many of you may know that she was an NSTS scholar in the year 1966. That is a year before me. And of course, I didn't know her during her student days because NSTS students met once in a year, but it was only the same batch students who met. So I came to know of her as a physicist only while I was doing my PhD. And because she had enrolled to do PhD with T.V. Ramakrishnan, and as a part of her PhD thesis was this Sur Ramakrishnan model for valence fluctuations. So I was doing experiments, and at some stage I needed to look at her model, whether I could take up some things from that model and use it to interpret my data. So at that stage, for me, it was just, I didn't even know at that time that she was an NSTS student. Sometime in the year 77, 78, when I had met T.V. Ramakrishnan in Bombay, and he made me aware that I have this model with a student at IIT Kanpur, whether that is useful for me. Anyway, to cut the long story short, I then became Kea's colleague at Punjab University, Chandigarh, from 91 to 94, as I served as a professor at the physics department of Punjab University. And since then, the bond has continued. And, I retired. I reached the age of superannuation at TIFR in 2012, and then this opportunity came to serve as a VC of Punjab University. But prior to it, during the centenary year of Homi Bhabha, I had made contact with Kea and Dharamveer to have a science symposium for the school students in Haryana. And Kea and Dharamveer had just created the Society for Promotion of Science and Technology in India in the year 2000. It is incidental that 2009 was the Homi Bhabha birth centenary year. So I worked together with both Kea and Dharamveer, and we had this first school science symposium for the school students of Haryana on the campus of Kurukshetra University. More than 2,000 students had been brought from all the schools in Haryana for this mega event in which some of the top scientists of the country came to participate because that was a Baba's birth centenary year, and it was one of its kind event where the school students from the entire state had been collated together to listen to people who had been colleagues of Homi Bhabha. So, and ever since that event has been organized in Haryana every year. But my contact with Kea and Dharamveer became more intense. And when I joined as a vice chancellor, by that time, Dharamveer had also retired. Kea also had crossed the age of 60, and now we were all together. And we thought of, work for the popularization of science amongst the civic society, enhance the spirit of scientific temper, etc., etc. So for a while, I used to be a casual participant in the events of SPSTI, but after I completed my term as VC Punjab University, then I became more frequent participant of SPSTI events, and Professor Pasi, who used to be the vice president of the SPSTI, when his health did not permit him to actively participate in those events, he suggested that I should take his place and also strengthen the MOU which he had signed between the Chandigarh chapter of NASI and SPSTI, that we should work together, where we should use our contacts in the science academies of India to bring the scientists to a civic society forum, and working together with an NGO would would be beneficial both for the society, fellows of the society, as well as the promoters of an NGO engaged in disseminating the scientific temper. And with Kia as a general secretary of SPSTI, her focus was always that we should do programs in which we reach out to the young girls in schools and colleges. So, and it is with this spirit, we are all working together, and we are very happy that this Indian National Young Academy of Sciences also sort of started to work with SPSTI, and today we are one of its kind platform in the country where the active young scientists who are working in their national labs or the academic institutions, they are working with the retired scientists and on an NGO platform, and this partnership is growing. And now we also have IIT Delhi, which is a premier National Institute of Technology, Science and Technology in India. IIT Delhi also has joined hands with SPSTI so that we can enrich the programs that we are doing together. So let me also use this occasion to recall that exactly 1 year ago, on this very day, last year in the year 2021, the TIFR had taken initiative to reprint and re-release the biography of Dr. Bibha Chaudhary. Okay, so Bibha Chaudhary is the first woman scientist to be employed by Homi Bhabha at TIFR. Okay, she came into the limelight because S.C. Roy and Rajinder Singh wrote a biography on Bibha Chaudhary in the year 2018. Till then, she had done wonderfully well when she entered into scientific career as early as the year 1938. That is just before the Second World War. Okay, and during the war years, she had worked with one of the then pioneering cosmic ray physicist or a nuclear physicist of India, none other than D.M. Bose. D.M. Bose was a nephew of the famous J.C. Bose, and and she had enrolled as a PhD student of D.M. Bose when D.M. Bose was still a part of the Calcutta University. So J.C. Bose passed away in the year 1937. D.M. Bose became the director of the Bose Institute. He left Calcutta University. But Bibha Chaudhary had continued to work on cosmic rays with him. So in those war years, okay, working all by herself with her supervisor, she had done a pioneering work using nuclear emulsion, photographic emulsion plates, which she had exposed to the cosmic rays by carrying those photographic plates to Darjeeling and going on the horseback and planting all those photographic plates on the top of the hills in the Darjeeling area, and then bringing and analyzing those photographic plates and looking for the imprints of cosmic ray, the interaction of high energy particles with the nuclei in the photographic emulsion. And by looking at those nuclear tracks, she had actually written a series of 4 papers in Nature, and those papers had this discovery of heavy electron. At that time there was this thing that there is a particle which has a mass of the order of 200 times the electrons, and it wasn't clear whether it was a strongly interacting particle or a weakly interacting particle, so whether it was a pion or a muon. But she had this discovery of a heavy electron having mass, which is of the right. So mass guess was right. The only thing is they didn't know whether it is a pion or a muon, and these papers were published in Nature. But if there was a little bit more work which if they had added, this surely would have fetched India the second Nobel Prize in physics before the war years. So that
Okay.
was the great importance of Vibha Chaudhary as a woman scientist in India, and
Yes.
she had been forgotten. And so Rajinder, this C. Roy and Rajinder Singh wrote this biography, and that biography caught the public attention. And then people in TIFR had actually forgotten that she was the first woman scientist to be employed at TIFR. She is not only the first woman scientist to be employed at TIFR, she also goes on to become the first woman scientist to be employed at PRL. So, this
Okay.
we have this movie, Rocket Boys,
Yes.
describing great contribution of Bhabha and Sarabhai. But
Yes,
that
sir.
movie has no mention of Vibha
Hero.
Chaudhary, because this movie is made for the masses. But let me add that Vibha Chaudhary, it's not that the Bhabha did not and Sarabhai did not know the importance of the work that Vibha Chaudhary had done. So Vibha Chaudhary arrives in TIFR in the year 1949, and she was, those today, if somebody comes with a PhD from abroad, you will at least be given a respectable title. But this
Yes.
is, we are talking of 1949. TIFR was just 4 years old. There were no respectable titles.
Okay. Yeah.
Okay, so she was, and there were no salary grade for scientists per se as well.
Okay.
So she was put in a salary grade, which in today's parlance will be as if it's a salary grade for a scientific assistant.
Okay.
Senior scientific assistant. So she was called a research fellow. She was given the salary grade, which is not a grade of an officer, but there were no salary grades for the scientists at all. The grades for the scientists come into being only after the Atomic Energy Commission gets established in the year 1954. But Vibha Chaudhary leaves the IFR after spending 4 years, and she goes back to Calcutta. Then she goes and joins a college, an engineering college, for after a year. She wanted to be back at Calcutta. Somehow she wanted to be back at Calcutta. So she went back at Calcutta. There was no compulsion. After all, he had been given a house to live in South Bombay at that time. But her desire to go back to her city of her birth and so on, so she goes back. Things don't turn out well. Then she goes back to Europe, and then she was in MIT for a while. Then at some stage she joins Sarabhai in physical research laboratory. Okay, then she stays at physical research laboratory, and people, the folklore is that Vibha Chaudhary, as a first woman scientist, did not get her due at the hands of the rocket boys, Bhabha and Sarabhai. But it's not that they didn't know that how talented she was and what is the quality of work which was to her credit. After all, her discovery, redone by C.F. Powell in England at Bristol, got Powell the Nobel Prize in physics of the year 1950. It's only 10 years later, while writing a book, that Powell acknowledges that they picked up the threads from Vibha Chaudhary and from that work, and repeated those experiments with the better photographic plates, analyzed it well, and the Nobel Prize to Powell does not say that he discovers pion. It also says he develops these nuclear emulsion techniques, which leads to the discovery of pions. If it was just pion discovery, then Vibha Chaudhary would have been given would have shared the Nobel Prize with Powell. But the Nobel Committee didn't do. So Nobel Committee also didn't do a good job and didn't treat a woman scientist from a developing country, from of a British colony properly.
So this is the problem.
If it is today's globalized words, Vibha Chaudhary would have
certainly
shared the Nobel Prize of the year 1950.
Certainly, sir. Yes, sir.
Okay, so so that is how then I sort of took up the initiative that we must have a reprint of this book on behalf of the TFR Alumni Association, etc., etc., etc. So today we have a named lecture which is nationally awarded in the name of Vibha Chaudhary. Some 9 women scientists were chosen last year, and lectures were announced in the names of those women scientists. One of those lectures is in the name of Vibha Chaudhary. So the first Vibha Chaudhary lecture was delivered at PRL Ahmedabad last year. Okay, so at our forum at Chandigarh, we can have a Vibha Chaudhary lecture.
Absolutely, sir. Yes, sir. We should. Yes,
sir. So, I mean, it is that partnership only which has grown. Today, Rajinder Singh has written 2 biographies of a scientist from Punjab University. Rajinder Singh has just finished writing 2 books, one on the biography of B.M. Anand, the first head of the physics department of Punjab University, and of Professor Suman Beri. Biography is also in print. It's in print. The first woman emeritus professor in physics of Punjab University. Her biography is in print. That biography is in print. So since last year, so I came in contact with Rajinder Singh only for that book last year. So from the year 2021 to 2022, in this last 1 year, the 2 biographies has come up, which pertain to women scientists of Punjab University, Chandigarh, and 2 scientists of Punjab University, Chandigarh. One of them is a women scientist, namely the first woman emeritus professor in physics. Actually, she is Kia's colleague. Kia has known her as long as she has been at Chandigarh. I don't know whether someone has joined today's event. I didn't see the list of participants. So I don't know whether she's here. So
Suman is in Kurukshetra University today.
Okay, so in any case, this, as I already stated, that we have this INYAS Zoom link. So here we have only the panelists here. Rest of the people are watching on YouTube. So only those who are going to present their work. So 5 researchers we have, female researchers. So now, so they are going to present their work.
I mean, we could have a chat show just to release Suman Beri's book.
Yes, sir. Thank you, sir. Thank you for these suggestions.
Suman Beri's foreword of that book is written by none other than Bindu Bhamba. Bindu Bhamba herself is a high energy physics woman. Thing. She is at University of Hyderabad, and she has just superannuated a few months ago. So she has written the foreword of that book.
Okay, sir. Okay. So this is why we need these kind of days. That is why this time we have invited 5 researchers, female researchers, and they are going to present their work today. So this is what we wanted, you have actually stated also, that we have undermined actually the importance of the scientific work that has been done primarily by women. So they have not been given that importance as compared to their men counterparts. So this is exactly the reason we have invited these young researchers today. Thank you, sir. Thank you very much, sir.
I can just tell you more stories, but I think I have done enough.
Thank you, sir. Your stories are always an inspiration for us. In fact, we didn't know so many facts which you have just shared with all of us. Thank you so much, sir. Thank you very much for your inspirational words and also your inspirational stories also, and letting us know about the history of women in science. Thank you so much, sir. So now I would request Dr. Suman to kindly start with the presentations. If you can introduce, ma'am, our first participant.
Yes.
Suman, ma'am, please.
So our first speaker will be Dr. Rasheed Patel. As I mentioned earlier, she is the senior scientist and validation team head at Imago and Getter, Mumbai. This is a healthcare and pharmaceutical-based disinfectant company.
और 10 मिनट
She is PhD in microbiology from University of Mumbai, and she has more than 12 years of industry experience, which is unique in itself, with about 8 years experience in TCS Innovation Lab, TRDDC Pune, and she has been involved in low-cost water purification solutions for removing microbial contaminants, arsenic and fluoride from drinking water. She had been the part of the innovators of Tata Swatch Nano Tech water purifier, which most of us might be having at our homes, and this was launched by Mr. Ratan Tata in 2009. She has about 15 research papers, 6 patents, and book chapters in her kitty. So we are welcoming Rashri Patil to share your experiences and your science work to motivate all of us and young researchers also. Welcome, Rashri. You can share your presentation.
Good morning all, and thanks for providing me this opportunity. I will share my presentation. Is the slide is
not yet? It might be.
Is it visible?
Not yet to me. Others, are you able to see?
No, Rashi, we are not able to see right now.
Just a second.
Okay.
Can you see?
Yes.
Yes, yes. You can change to the full screen. Yeah. Perfect, perfect.
So thank you all again. So in this presentation, I will be discussing about the portfolio of water purification solution that has been developed by our team at TRDDC Pune for removing microbial and inorganic contaminants from drinking water. Actually, these solutions are for the rural people. It is designed in such a way that rural people and low-income households at urban areas can use it. Before starting any concept, we have given 3 criteria for it. It should be low cost, and even if it is low cost, it should not be of a low quality. This all the technology has rigorously tested as per as the USCPA guideline for removing 6 log of bacteria, 4 log of viruses, and so on. So I will be presenting this technology, what we have developed. So I will start with the problems, water problems in India. So providing safe drinking water is the biggest challenge in our country. So water stress, that is unavailability of water, water stress, unavailability of water, and contamination of water with inorganic and organic material, and the huge losses that we are facing due to waterborne diseases, due to microbial contaminants. Everyone is know about this. And I'm stuck with my slide. Hello.
Yeah, we are on this slide, India's water problems.
Yeah, it is not moving. Yeah.
Now it is moving. Yeah.
Yes. Sorry for this. Actually, apart from this microbial contaminants, arsenic is also posing a huge problem. If you see 80 millions of people in India and Bangladesh, they are suffering due to this arsenic problem. And arsenic is called as the largest mass poisoning in human history. So similar to arsenic, fluoride contamination is also crippling most of the population in India. You can see in this picture, the legs and the feet of the people, they are bent. So it is due to fluoride contamination in groundwater. So realizing the problem, the scientists at TCS Innovation Lab, TRDDC, they are working since from last 2 decades on developing a low-cost water purification technology specifically for household population, specifically for rural household and low-income urban population. So this is first attempt of DRDC. We have developed this rural water filter. You can see this is basically a composite bed of RHA and pebble, and cement is used as a binding agent. So it creates some porosity, and it can able to trap bacteria and some turbidity to an extent of 80 to 90%. And this different NGOs and communities, they have thought to fabricate this filter, and it has been distributed across India in almost 7 tests. Around 30,000 of Sujal filters are deployed in rural areas, and around 1,500 Sujal filters has been deployed during the Gujarat earthquake and Asian tsunami. So as I said, that this filter is fabricated only just with RHA. RHA is a rice husk ash, which has some capacity to purify water. And it is not expected to meet the international standard because it doesn't have any disinfectant releasing system at all. And also the pore size of the bed, you cannot reduce for to an extent below certain point. So it is not meeting the international standard of removing bacteria and viruses. So what we thought at TRDC to make a water purifier which can give a water of a quality which meets the international standard. So it was thought that what if we can give the disinfectant releasing capacity to that purification media. So here the process has been developed to impregnate the rice husk ash with nano silver. So the process has been developed and it is giving a good this nano silver. When it releases into water after the water passing through the media, it gives a good bacteria reduction at a rate of 6 log. This project, this Tata Switch project was initially collaborative. It's a collaborative project between Tata Chemical and TCS. So initially, what has been decided, we will prepare cartridge out of this purification media and sell this cartridge. Like here, you can see the filter cartridge and pre-filter in the form of loose cartridge in a grocery shop, so that people can buy it as a cost of 100 rupees or 200 rupees, and they themselves can plug it on their matka. You can see on top for container, you can fit this cartridge, and bottom matka you can keep for collecting the purified water. So this was the original idea, to develop the cartridge and provide it as a loose part the groceries. So these are the different product development stage when we are developing this technology. Initially in the laboratory, we are trying a different configuration. This RHA, you can see that we have prepared by cutting the football and make it a hemisphere, and we have developed this. Eventually, there is a lot of development has started coming, and we have packing this bed purification media in the container. And this green container, you can see this is the final product, what we have developed. It is a 3D printed cartridge. So from Sujal to this final prototype, I think 2 to 3 years has passed by coming up to the configuration. This is the final configuration of the inside of this cartridge, what we have developed. This is the laboratory prototype. Initially, the flow of water to this cartridge was in a forward flow, but later we realized that if we give the reverse flow of water, that the performance will be much better, and there is a less clogging. So this is the internal configuration of the Tata Search water purifier. Here you can see that water flow is in a reverse direction. So this is we have finalized this configuration of Tata Search. Whatever objective we have said, that developing a cartridge which is give the quality of regulatory guidelines, that is finished. So this prototype, this is a 3D printed prototype, and you can plug it on the matka, and water can be treated. So this prototype we have tested across India in different laboratory and abroad also, and it's satisfied the US EPA regulatory norms of killing 6 log of bacteria and 4 log of viruses. So this design has finalized. It is giving a good quality water as per standard guidelines. But eventually, what happened? The initial matka concept. There are a lot of discussion, input from marketing team, and the senior management has taken a decision. We will drop the concept of this matka. Even the technology is same, the cartridge is same. But now the purifier, the marketing team, and the senior management, we are scientists, we are just doing research. We don't know about why the decision has been taken. The decision has been taken to, instead of this Matka purifier, we will launch the entire purification device of a tabletop household water purifier. So this tabletop household water purifier with a very attractive design of a cartridge as well as container is launched in the Indian market by Mr. Ratan Tata in late 2009, and it is the first low-cost water purifier which is launched in Indian market by Mr. Tata. So by that, at that time, what happened? Immediately, within 2 or 3 days, all the purifier means available in the market, they dropped their prices. So now, at that time, this similar kind of tabletop purifier, it's available at 3,000, 2,500. Now they have also reduced the price. So I think it's good. Means people got a good technology at reduced price for not for Tata, but for all the other brands. So this is about Tata Swatch. It got several national and international prizes for design and all these things. So we have a team of 4 to 5 people from our NTRDC and who involved in this activity. I was working as a microbiology head, and all these validation thing and the certification thing has done under guidance of me. So this is about Tata Swatch. So after this launch of Tata Swatch, TCS and Tata Chemical, we got separated. So in TCS, TRDDC, our group has started working towards optimizing the technology. So this is the first compact water purifier cartridge that we have developed at TRDDC. Actually, this if you see the cartridge, this has additional feature. This is an advanced version of Tata Switch, you can call it. It has many additional feature. You can see the bed is solid, and in addition to bacteria and viruses, it can also reduce protozoa. Actually, Tata Switch, because it has a loose water purification media, even though it is coated with nano silver, it cannot remove protozoal cyst because it is protozoan cysts are highly resistant to disinfectant. And this cartridge has a capacity to reduce the protozoan cyst also. And the cost of this cartridge is half to that of Tata Switch. And one additional feature is in it that this technology is work on synergistic disinfection action. Two disinfectant releasing system are provided into this nano silver as well as low volume of chlorine. So its performance is much better than Tata Swatch. It works at a very low contact time. So this is the purifier. It's an advanced version of Tata Swatch. Coming to the next, in parallel also we are working on this arsenic removal filter. You know that arsenic is also a big challenge in India. So this cartridge we have come up, it meets WHO and US EPA standard of removing arsenic, and it also can treat 2,000 liter of water. This is also developed at our center. And we have tested this fluoride arsenic removing cartridge at Karnataka district. In Yadgir, there is lots of problem of arsenic. So we deployed in few houses this arsenic removing filters and take feedback from the user. See, it is very important when you develop something in the lab. Until and until you test that thing in the field, you don't understand what surprises are coming. So after this field trial, we got some feedback from the user. What they are saying, the flow rate and the capacity of that cartridge is not sufficient to handle their need. So based on the feedback of user, we have developed this arsenic removing cartridge of a very high capacity. It can treat 8,000 liter of water and is sufficient for a large family. Similarly, we have also developed a solution for removing fluoride from drinking water, and also it has treat 500 liter of water. See, concentration of fluoride in water is at a ppm level, whereas arsenic is present at ppb level. So that's why its life is low as compared to the arsenic. There is much to say about the different technology, but because of limited time, I'm not going in detail about the technology. And one thing is sure that in this arsenic and fluoride filter, we have also integrated a microbial removing mechanism. So in addition to arsenic and fluoride, it also removes microbial contaminant that is also as per the US EPA standard. So this is a innovative portable water purification device that we have developed. That see, water purifier, filtered water you can get at home. But what if when you are going out? So this purifier is a portable pen. It is a purifier only. The entire purification mechanism is integrated into this cap. So this is a pocket purifier. Whenever you want to go out and you are suspecting maybe at that place water is not of a good quality, you just carry the pen in your pocket and go. And if you get a glass of water, just stir it for 30 seconds. You will get a reduction in microbial contamination as per US EPA guidelines 6 lot. It is capable of reducing to that extent. And it can last for 1,000 uses. Means around 500 liters of water it can treat. We can make it large, but then also some business thing has come. Then who will buy that again? So it has make only for 1,000 glasses. And if made available, it can just come at a cost of, I think, less than 30 rupees. It can be available. Okay. And this is for treating a glass of water. Similarly, based on the similar concept, we have developed a shoot stick for treating a 10 liter of water or bucket of water, because we have tested this at field and all that. So they wanted a big kind of thing so that they can treat large volume of water. So we have developed this shoot stick, which can develop a large volume of water. And this is the field trial we have done at Bastar, Chhattisgarh. This is the most innovative technology that our team has come up. This is called a funnel water purifier. So with should the pen and should the stick, there is a limited that you can treat a 10 liter or 20 liter of water. But with this funnel, any volume of water you can treat with a very precise dosing of the disinfectant. You can see this card, the mechanism is fitted into this. This has optimized in a way that these holes are optimized in a way that it can release a very precise concentration of water even if you pour 100 liters of water through it. So it is very portable. You can carry it anywhere, keep it at your home. Just you have to do is to add water to this funnel purifier and your water will get rid of microorganism. And the replacement cost of this is just 5 to 10 rupees. It can treat 10,000 liters of water, and if you wanted to change after the disinfectant is over, it can come at a cost of 5 or maximum 10 rupees. So this is again a versatile solution that our team has come up. What happened? We have developed different technology, but we are not getting any manufacturer to scale up the thing or to take it into the market. So what concept we have developed is a Tino filter, 3-in-1 filter. The user can fabricate their own filter by taking the plastic item from the market, and depending on the type of contamination found in their groundwater, like arsenic, in some part arsenic is there, in some part chloride is there. So what we have decided, we can sell this purification media in the grocery shop or to some distributor. The user can fill the purification cartridge in the box and they can fit it. All these pamphlets and all that will be given the written instruction how to connect that thing. And the funnel purifier is available. Funnel is available everywhere, and the cartridge costs just 5 to 10 rupees. You just plug it. When you pass the water through it, to the funnel, the microbial contaminants get removed, and the purification bit, depending on what type of contaminant you want to remove, it will get clear out. So what happened now? You don't need a manufacturer, or you don't need to set up a manufacturing unit to fabricate such devices. And the cost of this entire thing is just 200 rupees. So you will get an entire set of purification thing at the cost of 200 to maximum 300 rupees. So this is mainly to get rid of searching a partner to develop, to set a factory and all that. This is another membrane filter based handheld device. What happened during that time? A scientist from German has visited our lab. What he said us, okay, all these devices, they are based on this disinfectant system, but in some part of world and in our country, we don't use water treated with disinfectant. Chlorine is totally banned. So then for that situation, we have developed a membrane-based handheld device. So you can carry this anywhere, and you can just put it into the water and pump it. So water will come through the membrane, and you will get purified water, which is remove bacteria, viruses, and protozoa also. So this is one of the handheld device we have developed at TRDDC. So to say these are the low cost water purification solution we have developed with my team at TRDDC, Tata Swatch, which is available in the market, and it is doing very good. And the other purification technologies like compact water purifier, arsenic filter, fluoride filter, this pen purifier, funnel purifier, filter. Actually, we have tested these technologies vigorously. It is ready to scale up, but it is still in a search of some partners so that it can take it to the people. So I hope if available, if make it available, it will surely help to reduce the waterborne diseases and other challenges what we are facing in India and as well as in the world. I hope someday it will happen. So with this, I will finish my talk. Thank you so much.
Thank you, Dr. Rashri. It is wonderful to have a glance of the technologies which you have made. And these are really into the mission of government, where right to potable water to all. These are very economical technologies you have shown. And as you mentioned that once I heard that Mr. Tata saying that we are industrialists, not the businessmen. So this is in line with this. They are industrialists though, but they are having a huge take to the societal problems also. And in fact, they created the business for others also, while they reduce the prices and their sell also increase. Thank you, Rashri. Thank you for the wonderful sharing of technology. And it is actually leading to the technology for society. Thank you. Now, moving ahead, I would like to invite Ms. Poonam Yadav. As mentioned earlier, she is doing PhD from Regional Center of Biotechnology from Faridabad. She is a graduate in botany from Venkateshwar College of Delhi University, and she has done masters in biochemistry from Central University of Haryana. Her PhD interest is on engineering of bile acid derived nanomissiles for temporal targeting of tumor microenvironment. Poonam, you are invited to share your presentations, and since already due to time constraints, I would like to request you to restrict yourself to 5 to 7 minutes.
Sure, ma'am, and thank you for the warm welcome. My slides are visible?
Yes, please.
Yes, Poonam, yes.
Okay, so good morning, everyone. Today my presentation is entitled as, just a minute. It's entitled as Cancer Drug Delivery in the Nano Era. So I'm a researcher at the Regional Center for Biotechnology, located in Faridabad, and it is a part of NCR Biotech cluster consists of the 5 different institutes. Our lab, named as Laboratory of Nanotechnology and Chemical Biology, mainly work on multidisciplinary domain such as synthetic chemistry, nanotechnology, cancer biology, genomics, lipidomics, cancer biology, microbiology, and immunology to basically address different challenges in the area of cancer biology and infectious diseases. And we develop biomaterial for the effective therapeutic approaches. So for me, as today we are here to celebrate the International Day of Women and Girls in Science. So for me, science is just a fun and exciting, and it gives us the opportunity to learn something new every day. And it has the power, it gives us the power to change the world. So there are many women in the field who inspired the world through their breakthrough discoveries and achievements. I have listed few of them here, like the first one is Gertrude B. Elion, who won the Nobel Prize in 1988 and shared with George H. Hitching and Sir James Black for their use of innovative methods of rational drug design for the development of new drugs. The second is the Francoise Barry Sinsoy. So she won the Nobel Prize in 2008 together with her former mentor for the discovery of the HIV virus. The most recent name which we all heard is the Jennifer Doudna, who shared the Nobel Prize for the development of the method for genome editing CRISPR-Cas9 in 2020. So from their achievements and their recognition in the field um, is very encouraging for all the women in the field who are in science, and even motivate the other girls who just want to pursue science in future. So it is well said by Marie Curie, who was the first woman in the history who won Nobel Prize, that we must believe that we are gifted for something, and that thing at whatever cost must be attained. So today I'll discuss about the cancer biology and the drug delivery through nanomedicine. So I'll give the brief introduction about the cancer. So cancer is the second leading cause of death worldwide, exceeded only by the cardiovascular diseases. A normal cell become cancerous when they acquire gene mutations responsible for cell division, cell death, and other mechanisms. And it is due to certain genetic alteration, environmental changes, or due to some chemical carcinogen. These cancerous cells acquire certain characteristics such as sustained growth signaling, loss of growth inhibitors, unlimited cell division, and absence of the cell death. These generate a mass of cell which we can say tumor, and these tumor uh, activate the growth of blood vessel in these cells, and which lead to the invasion and metastasis. The invasion and metastasis basically help the tumor cells to invade in the local tissues and also spread to the other body parts also. So these characteristics of the cancer cells are mainly known as the hallmark of cancer. So there are various treatment strategies already available for the cancer treatment, and out of them, the surgery and the chemotherapy are the most primarily used treatment options. But there are certain limitations associated with these conventional treatments, like they are highly non-specific for the disease site, which mainly cause the severe side effect. There are lesser physiochemical stability of drug in the body, of free drug mainly in the body, and the poor pharmacokinetic profile also causes the increase in the number of doses of drug for the treatment, and which further increase the antibiotic resistance. From nowadays, there's a lot of research is going on for uh, there are a lot of researches going on which lead us to various advanced treatment options, and these advanced treatment options give us certain advantages, such as they accumulate at the target site of the disease, which basically reduces the drug induced toxicity. It also improves the physiochemical stability of the drug in the body, which further help in improving the pharmacokinetic profile. So all these property basically leads to the reduction in the number of doses for the treatment, which help in the better treatment and lesser toxicity. So one of the advanced treatment strategy is the nanomedicine. So nanomedicine is key emerging technology of the 21st century, and it is an interdisciplinary field where nanoscience, nanoengineering, and nanotechnology interact with life sciences. So nanotechnology are broadly divided into 5 different categories, like lipid-based nanocarrier, polymer-based nanocarriers, drug conjugates, viral nanoparticles, and inorganic nanoparticles. These nano-sized drugs basically accumulate at the tumor site due to the leaky blood vessels, which is the key feature of the tumor blood vessels, and also retained these nanomedicine at the tumor bed due to the poor lymphatic drainage from the tumor site. So this process is known as the enhanced permeability and retention effect, the EPR effect. This EPR effect basically allows the nanoparticles of appropriate sizes to accumulate more in the tumor tissue or cancerous tissue than in the normal tissues. So in our lab, we explore bile acids as a drug delivery vehicle, and bile acids are facially amphiphilic steroidal molecules which mainly derived from the catabolism of cholesterol. They have excellent chemistry, having different active functional group, which mainly help in the conjugation of different molecules and different drugs at their site. These bile acids have the ability to aggregate into the supramolecular structures such as micelles with dietary fatty acids, phospholipids, and other drugs. So we synthesized in our lab the estrase sensitive lithocholic acid, which is a bile acid, lithocholic acid, phospholipid, and docetaxel conjugate named as LCA-DTX-PC. This LCA-DTX-PC form the micelles, but to provide the shield property so that we can avoid the rapid clearance from the blood, we also synthesize the pegylated lithocholic acid. So this pegylation, this PEG unit, which is a polymer, it will help in to avoid the clearance from the blood. When we mixed these LCA-DTX-PC and LCA-PEG in 1:1 ratio, so these both self-assembled and form the supramolecular DTX-PC nanomicelles, which are having the size less than 100 nanometer. And the conjugation strategy provide the prodrug character, which mainly maintain the slow and sustained release at the tumor site. Then we checked the size of these nanomicelle and found that the nanomicelle are approximately 60 nanometer in size. And through the transmission electron microscopy, we checked the morphology and the size, which we can see that these nanomicelles are spherical in shape and having the size of from 20 to 60 nanometer. Then, as it is already mentioned in the literature, that the tumor tissues has high level of esterases at the site. So we use the esterase sensitive linker to link our drug to the lithocholic acid. So we check in the in vitro to that this docetaxel is able to release from the conjugate or not. So from the in vitro drug release assay, we can see that in the presence of esterase 100 unit, this docetaxel is released with time. Then after checking the release and the size, we further check the toxicity of these DTX-PC nanomicelle and compare with the already marketed formulation of DTX, that is Taxotere. And when we check the toxicity, we measure the change in the body weight by giving the multiple doses to the mice. So from the body weight change graph, we can see that in case of DTX Taxotere formulation, the body weight is reducing even greater than 15% with 20 mg per kg, the highest dose. But in case of DTX-PC, we can see from with all the doses, there is no reduction in the body weight. Then we also check the survivability with the different doses by giving the multiple administration of the DTX Taxotere formulation and DTX-PC formulation. So from the survivability graph, we can see that all the mice having the 20 mg per kg dose died in DTX Taxotere formulation. But in case of DTX-PC, all mice were live, there was no death. So we can conclude from the data that these nano formulation of docetaxel exhibit higher tolerability, reduced toxicity, and sustained release of drug, which make it an ideal drug delivery vehicle. Then we also check the anti-tumor efficacy of these DTXPC nanomycel in the breast cancer tumor model in mice. So we injected the 41 tumor cells in the mice, and after 5 to 6 days, we divide these mice into 3 different groups. The first group is untreated, the second is DTX taxotere formulation, and third is DTXPC nanomycel. So we give 5 mg per kg of dose to the DTX taxotere and DTX PC nanomycel group and check the body weight and the tumor volume on the alternate day. So from the tumor volume graph, we can see that the DTX PC nanomycel is able to regress the tumor volume significantly in comparison to the other groups. From the body weight change, we can see that these DTX PC nanomycels are not causing any acute toxicity to the mice as there is no major reduction in the body weight. But from the DTX PC DTX taxotere formulation, we can see greater than 15% reduction in the body weight. In the end, from the pictures also and the last day tumor volume, which also indicate that this DTX PC nanomycel exhibit the enhanced anti-tumor activity than the DTX taxotere formulation. We have published this. I have not shown all the data due to the time limit, but we already published this data in the article published in Angiochem in 2021 entitled as Bile Acid Tether Docetaxel Based Nanomycel Mitigate Tumor Progression Through Epigenetic Changes. This article having the study was published in the Hindu, and we basically two of my senior and me have worked on this project from last 5 years. Thank you. I'm happy to take questions.
Yeah, thank you, Poonam, for this wonderful presentations. And you are really taking nanoscience to the societal applications where they can find actual application. Most of the time we keep our nanoscience to the laboratory only, but you have extended your research to the actual testing and actual applications, and you have carried out the testing with the animal subjects also. I hope very soon you will be able to see this technology transfer to some other manufacturers. Thank you, Poonam.
Thank you, ma'am. Thank you.
Questions in chat box, Nishima, in YouTube?
I'm not seeing any questions on YouTube as of now. If any of the members here on the panel, they wish to ask something, even from Rajshri or Poonam, they can please go ahead. The other speakers, if they want to ask something.
I don't think there are any more questions.
Yeah, Poonam, if I can ask you one question.
Yeah, ma'am.
Yeah, so you have made nanomycels, right, for this tumor progression.
Yeah, right.
I'm not sure if I saw that slide. So how do you think these are better than the other nano formulations? You know, there are so many nano formulations that are being developed nowadays. So
yeah,
how
ma'am.
is your bile acids better than those formulations?
Ma'am, actually, usually when you look there, or there are always the encapsulation of the drug is there in case of the liposome and other nanomycel. But there is no control over the release of drug in those cases. So to avoid that, what we have done, we conjugated our drug so that there will be control over the release, because there is a high level of estrase present at the tumor site. So there will be release of drug at the tumor site only because we conjugated our drug with lithocholic acid. And this phosphocholine moiety will help in the internalization of the drug in the tumor cells.
Okay, so in a way you have, instead of passive targeting, there is active targeting in this case. So you're selectively targeting the cancer cells?
No, we can't.
Selective? No.
Targeting is through the passive targeting only, because these nanomycel will is not having any particular marker on their surface or anything for the active targeting. but they have the size of approximately 60 nanometer, and as the drug is conjugated, so drug will not released in the system without like there is a control over the release of the release of the drug due to the conjugation strategy, because without esterases this drug will not be cleaved from the conjugate.
Okay, so it is a controlled drug delivery system.
Yeah,
yeah, in comparison to other uncontrolled maybe drug delivery
exactly.
systems.
Yeah, right.
So is there any possibility if you can make it an active drug delivery system, like you already said?
Yeah, actually we are working on this right now. We are trying in our lab. This project is already going on, so hopefully we are soon going to show some data in that also.
Great.
Without esterases, this drug will not be cleaved from the conjugate. Yeah, because there is a linker
Drug
present.
delivery system.
Yeah.
In comparison to other uncontrolled maybe drug delivery
Exactly.
systems.
Yeah, right.
So is there any possibility if you can make it an active drug delivery system, like you already said?
Yeah, actually we are working on this right now. We are trying in our lab. This project is already going on, so hopefully we are soon going to show some data in that also.
I think probably the YouTube link is playing. If you
ma'am, actually I'm also
if you can please mute it. Yeah, because the same question was playing again.
Exactly.
Yeah, that's it. Okay. Okay, so if there are no more questions, you can stop your screen sharing.
Thank you.
Yeah, thank you, Poonam. Next, moving to the third speaker, we have Ms. Deepika Sharma with us, who is a senior research fellow at chemistry department at PU. Deepika, are you here?
Yes, ma'am. Yes, ma'am.
Her brief introduction is she is Masters in Chemistry from Department of Chemistry and Center for Advanced Studies. She has also worked as Assistant Professor in Applied Sciences at Chandigarh University, and she is among 19 rank in the National Eligibility Test Lectureship. Her main research areas are peptides and protein-mediated synthesis of metallic nanostructures, their structural elucidations, and potential application in the field of biosensing and bioimaging. Further to this, her research work includes determination of various environmental pollutants and biosubstrates. Along with this, she is also working on some therapeutic applications of these novel metallic nanoparticles. Over to Deepika. You can share your presentation.
Thank you so much, ma'am, for this warm welcome. And I would also like to thank the INYAS and the Vice Coordinating Committee for inviting me to this session. With this, I will start my talk, ma'am. A very good afternoon to all. The topic of my presentation is technological advancement in sensing methodology for detection of pesticides. So before I talk about the technological advancement, I would like to introduce what are the problems associated with the pesticides. So these pesticides are basically any kind of substance that are used to kill, repel, or control certain form of plants or animal that are considered to be a pest. And if we look at the global consumption of this pesticides, you can see in this world graph that among all the countries, China consumes the maximum amount of pesticides in terms of kg per hectares, followed by South America, Canada. India stands somewhere between 0.29 kg per hectares. And if you look at the data for pesticides trend in India, you can see that it has tremendously increased from 40,000 to 60,000 tons per year. And if I talk about the state-wise consumption of this pesticides per kg per hectare, Punjab stands for the first, followed by Haryana and then Maharashtra. So we have seen that these pesticides have been heavily used in the environment, so they can possibly travel in the environment and cause many environmental contaminations such as land, water, and air. These pesticides are volatile and can be present in air and can be easily present in water and is very endangered to aquatic species. And these pesticides on exposures, either it is direct or indirect exposures, can lead to many health hazards to humans such as nausea, headache, skin irritation, birth defect, cancer, Parkinson's disease, central nervous system damage, genetic damage, and so on. So we have seen that these pesticides can cause a very severe damages to environment as well as to humans. So if I talk about some of the incidents related to this pesticide poisoning, so there was a report last year which said that approximately 6,600 farmers die of pesticide poisoning every year in India. And there were few more cases which has been reported in Maharashtra and Nagpur that that around 50 farmer deceased due to this pesticides poisonings. And if we look at the data, that is due to, that reveals that the deaths from unintentional poisoning from these pesticides, that you can see this is quite surprising, that although India doesn't have that amount of pesticide consumption per kg per hectare, but it stands very high in terms of death rate. And this is only for unintentional death rates. So as I have introduced you to the problem, so why these pesticides are so harmful? So what basically happen is that these pesticides basically act as an inhibitor on ACHE enzyme. So what are this ACHE enzyme? So this is an acetylcholinesterase enzyme. This is present in a body, and this is mainly present in central nervous system, and this is used for the hydrolysis of a acetylcholine, which act as a neurotransmitter. So what is basically happening is that in ACHE enzyme, there are two sites present. One is esteric and one is anionic site. So this acetylcholine interacts in this esteric site and leads to hydrolysis into acetic acid and choline. But if these pesticides enter into a body, they basically block this esteric site and form a very strong phosphorylation bond, due to which now this acetylcholine cannot bind to this site, and there will be an overaccumulation of this acetylcholine and can actually lead to neurotransmission disruption. So among all of the pesticides, today I will discuss about the ethyl parathyne, its adverse effects and method for its determinations. So what is ethyl parathyne? It belongs from a class of organophosphorus pesticide. It is commonly used as insecticides. It is highly toxic and it is a very effective inhibitor to this brain acetylcholinesterase. It leads to the imbalance of acetylcholine and can lead to many serious life-threatening diseases such as Parkinson, asthma, and so on. So if I talk about what are the conventional method for its detections, they are such as GCMS, HPLC, capillary electrophoresis. But this conventional method has several drawbacks, such as they are very time-consuming, high cost of instrumentation, and very skilled workers are required for this. So in contrast to that, we are using some more recent techniques nowadays, were like electrochemical immunoassay, surface enhanced Raman scattering, colorimetric and fluorometric based techniques. So today I'll be talking about the fluorometric based technique for the detection of ethyl parathyne. So this is the sequential progress of work. So first of all, we have synthesized the protein mediated bimetallic gold silver nanoclusters, and then we have developed an enzymatic based sensing methodology for detection of ethyl parathyne, and then we have proposed a device for on-site detection of this ethyl parathyne as well as other pesticides. So this is the overall scheme where this BSA capped gold silver nanoclusters have been used as a nanoprobe for the determination of ethyl parathyne. I will discuss this scheme in a later slide. So first of all, I would like to discuss about how we have synthesized this gold silver nanoclusters. So this is a schematic representation of this synthesis. So we have taken a BSA and have added gold salt to it to make a BSA gold complex, followed by silver additions and allowing the reactions for overnight in basic pH, and we get a BSA capped gold silver nanoclusters which are inherently fluorescent. When we excite them at 322 nanometer, they emit at 650 nanometer. If I talk about what are the advantage of using this BSA, so this BSA is like easily available proteins, and it leads to one-pot biomineralization synthesis of this water-soluble NRI emitting nanoclusters. Basically, now in this case, BSA is playing as a dual role of reducing and stabilizing agent, because BSA has many proteins. It has 35 pair of cysteine amino acid that can stabilize the synthesized nanoclusters, and at tyrosines they can reduce the nanoclusters, and synthesis has been carried out at ambient conditions. So the followed by the synthesis, we have carried out the characterization for this BSA capped bimetallic nanoclusters. So in graph A is the for absorption graphs, and here we can see that this nanocluster doesn't show any plasmonic peak, and they show a very broad peak corresponding to the nanocluster formation, and ruled out possibility of a large size plasmonic nanoparticles. And from graph B, it is a fluorescent spectra depicting its emission at 650 nanometers. And from graph C and D, we determine the size of this nanoclusters. The C graph determines its hydrodynamic size, which was around 16 nanometer, and from TEM and HRTEM, its size was 5 nanometer. It is only its small size that makes it as a fluorescent, and further it was characterized using XRD and EDX. And now this is the developed sensing scheme, which we have developed for the detection of ethyl parathyne. In the first steps, what we did was that we have added the copper to this BSA capped gold silver nanocluster, which leads to its quenching of its fluorescence. And now it is in off state. So what we are doing next is that when we are adding this acetylcholinesterase enzyme to this acetylcholine, its substrate, basically now this ACHE hydrolyze this and form thiocholine. Now this thiocholine shows a very strong bonding with the copper ion, and it removes from the surface of nanoclusters, and again this is in on state. So what happened when ethyl parathyne or any other pesticides is present, it actually blocks its active site, which I have discussed previously, that it will block its site, and now due to its blockage of site, this acetyl thiocholine will not be hydrolyzed to this thiocholine, and this BSA capped gold silver nanocluster and copper ensemble will remain in off states. Thus, by varying the concentration of this ethyl parathyne, we can monitor the signal and can determine the ethyl parathyne in the solution. So this was the optimization of reaction parameter. First of all, we have optimized the concentration of a copper that need to be added, and it was shown there that 9.76 micromolar concentration was the lowest concentration that can be detected, and this is a linear graph showing a very good relation. And further, we have optimized the other parameters such as the substrate concentration, because it is a fluorescence based technique, so we are looking that this substrate and enzyme should not affect its fluorescence intensity. So we have optimized the concentration of both acetylcholine and acetylcholinesterase enzyme. So from here, 20 micromolar concentration was optimized for substrate, and for enzyme it is 300 milli-unit per ml. And this is a blank. This is a controlled experiment where we have seen that this first one for the BSA capped gold nanoclusters, and one copper had added, it quenched, and all the substrate has not. Sorry, this E graph is for pH studies, because this is an enzyme-based methodology, and in this pH can drastically change the conformation of enzyme. So what we observed was that at pH around 7 to 8, this is a stable system, and we have carried out all the study at physiological pH 7.4. Next we talk about the sensitivity and selectivity of the developed assay, because whenever we develop some sensor, its sensitivity is a very important parameter where we have to find out what is the lower limit of detections. And here you can see that this shows a very good linear trend between 0.05 nanomolar to 1000 micromolar concentration, and the lowest limit of detection was 2.40 picomolar in our case, and we have also checked its specificity selectivity with other non-organophosphorus pesticides and organophosphorus pesticides. With non-organophosphorus pesticides such as Dufort, D and atrazine, it doesn't show that promising result, but with some other organophosphorus pesticides it shows some selectivity, but maximum for the ethyl parathyne that we have used. And further, we have also checked the applicability of this developed biosensor in real water and food matrices such as tap water, soil water, orange and apple juice as a food matrices, and we have observed that this developed sensor has shown a very good percentage recovery varying from 92 to 105, which further validate the applicability of the developed biosensors. As now we are moving towards the technology, how this technology has been making a progress in pesticides detection. So now there are few on-site sensing strategies and portable devices are for on-field detection of pesticide residue in agriculture and food products. Nowadays, people are more interested in making some device and fabrications and kit so that they can be used at on-site detections, and most of them are based on colorimetric techniques using some nanoparticle aggregation, label-free hydrogel particles, paper-based sensor, lateral flow immunoassay, integrated digital reader. So what are the advantage of this is that they are real-time detections and can be done with naked eyes. They are simple to operate. We do not need any specified trained person. They are of low cost and applicable. So I'll give a brief about two methods that have been reported. For the first one is on-site chip-based colorimetric quantifications of organophosphorus pesticides using an office scanner. So in this case, they have made a chip-based sensor using a very simple method, and they made it, and the color intensity was varied. In this case, they had used an additional DTMB reagent, which elements reagent, which is used for the colorification. The thiocholine that has been generated as a hydrolysis product reacts with it and give a yellow color for it. If pesticides is present, that yellow color intensity will keep on decreasing. So by this, they have quantified it and leads to the detection of pesticides in another method, such as embed light sensor-based colorimetric dipstick readers. In this case, what basically is happening, they are using a dipstick. It is just like a paper, and what they have observed is that without organophosphorus pesticides, it is of blue color. As we keep on increasing the concentration of a pesticides, it becomes white. Basically, when pesticides is present, the light the intensity of light actually decreases, and this with the ambient light sensor, they are basically determining the intensity of light that has been passed through this paper. So the next thing is that because most of the devices are based on colorimetric sensing scheme, so we are proposing a device based on fluorometric scheme, because we have already worked on that fluorometric scheme on a lab base, and our further goal is to make a device so that we can use it for the on-site detection of pesticides with some integrated data circuits. So what will be the advantages of this post kit? It will be very highly effective and sensitive for the picomolar level detection, because we were able to detect this ethyl parathyne at a picomolar level, so that it can be used for various kind of pesticide, because it's an enzymatic based strategy. So it can not be only used for ethyl parathyne, it can be used for other pesticides also, which are good inhibitor to this ACH enzymes, like other organophosphorus pesticides and carbamate pesticides. And this proposed device will solve the problem of complexity of sophisticated instrumentation for detection of pesticides. So this is just a proposed plan, and with this I would like to conclude that we have synthesized a BSA mediated gold silver nanocluster via green chemistry protocol. It acts as a dual sensor for the rapid and ultra sensitive detection of copper and ethyl parathyne. The enzyme based fluorescence sensor shows picomolar level sensitivity towards ethyl parathyne, depicting a very low LOD, that is 2.40 picomolar, and a good specificity when tested with other organo and non-organophosphorus pesticide. The developed assay is appropriate for the detection of ethyl parathyne in real sample, exhibiting its excellent reproducibility. And this paper got published in Talenta in 2021. Thank you.
Thank you, Deepika. very nice and practical application you have targeted for your research. This has been a concern, great concern among farmers as well as the consumers, because farmers have their own intentions to add, and consumers, they have their own intentions to have a good quality food. So any questions from audiences and members? If any member want to ask any question. I think Deepika, I
Okay.
will ask 2, 3. Is somebody asking question?
No, Dr. Suman, please go ahead.
Okay, okay. I have only 1, 2 questions for you, Deepika.
Yes,
Have you checked the agglomeration study of your nanocrystals?
Agglomeration studies, ma'am, like how stable they are, ma'am?
Yes, yes, yes.
Ma'am, they are quite stable for 3 to 4 months when kept at 4 degree at room temperature. If they are lyophilized, they are even more stable for 6 to 8 months, ma'am.
So after lyophilization, you get good quantity of your material?
Yes, ma'am. Yes, ma'am.
Have you tried?
Yes, ma'am. For many techniques, just as XRD and all other, I have lyophilized the samples, ma'am.
Okay. And you have talked about ethyl parathione.
Yes,
What
ma'am.
if I add methyl parathione?
Ma'am, it will also shows the results in that case, because this technique is based upon the inhibition of that ACHE enzyme. I have not checked up upon it, but yes, definitely this can be used with methyl parathyne also, ma'am.
Okay,
This
because
sensing.
in your graphs, you have showed that a maximum reactivity with your ethyl parathione, but
Yes, ma'am.
I think you targeted about phosphate group. So it should
Yes,
be
ma'am.
sensitive to other phosphate.
Yes, ma'am. Yes, ma'am. Maximum to phosphate group, it can be applied. Yes, ma'am.
Okay, and last question, what was the basis of using copper?
Sorry, ma'am, I couldn't hear.
What was the basis of using copper, not
Cop-
any other metal?
Ma'am, because copper shows the maximum quenching in first step. I have checked with many other metals also, and copper and mercury shows the best quenching for the first steps, but we cannot use the mercury because mercury forms a very strong binding with this BSA nanoclusters, which cannot be recovered if we add the other substrate.
Okay, okay. Thank you. Thank you, Deepika, from my side. Any other
Thank
question?
you, Deepika. So I just wanted to add, Deepika, that it is good that your sensor, what you're developing, is actually able to show group selectivity rather than pesticide selectivity, because then you will be able to actually detect a whole group. Sometimes we want to detect the whole group as such, right? So
Yes,
it is better in that sense.
yes, ma'am.
So yeah, so good luck to you for developing your kit now.
Yes,
Thank you for sharing your work.
thank you so much, ma'am.
Yeah, moving ahead in this event, now we have Neelam Vishwakarma. She is also a PhD scholar at CSIO. She has done her MTech in NIT Kurukshetra from material science and technology. She is BTech in IMS from IMS Engineering College Ghaziabad and in the field of biotechnology. Presently, she is working on the development of various detection platforms for sensing of disease biomarkers. She is interested in biosensors using nanomaterials for biosensing electrochemistry interfaced with the microfluidics. Anila, you are invited and please share your talk.
Yes, ma'am. Thank you so much for the introduction, ma'am. Good morning, everyone.
Good morning.
Is my slide visible?
Yes, yes, Neelam, slide is visible now.
Okay, thank you, thank you again, and a very good morning to all the people who are present here on this platform and on other platforms who are tuned into this program. First of all, a very huge and warm thanks to the platform for this opportunity here. I'm going to present my work on handheld device for monitoring the cardiac troponin level in human body. So, first of all, for a brief, just a second. Just, ma'am, there seems to be some technical issue. Just Can you see the next slide?
Yes, Neelam. Cardiovascular diseases, we can see that.
Yes.
Okay.
So, okay. So, for starting this topic, we first get to know what are the cardiovascular diseases. We all are briefly aware of the cardiovascular diseases like heart attacks, ischemic syndrome, etc. So there are a variety of the cardiovascular diseases, and these in total gain more than 30% of the fatalities or number of deaths in the world. What is a cardiovascular disease? Is in the cardiovascular diseases, there is an artery blockage which causes the blocking of supply to the heart muscles, and it in turn causes heart attack in humans. This is very crucial, because if the blood supply is blocked to the heart muscles start to die, and when enough number of heart muscles are dead, this causes the heart failure and the death of the person.
Neelam, I
Yes,
think
ma'am.
we have little bit time constraint, so can we come directly
Yes,
to
ma'am.
the technology part?
Okay, ma'am.
Thank you. Yes.
So these are some market surveys that we did while starting this topic. We found out that either there are the number of tests or the options that are available to common people are either very costly, that they use the chromatography techniques or immunochromatography, ECLIA, etc. ELISA, which is enzyme linked immunosorbent assay, and due to these things, they require very sophisticated instruments and very skilled technical labors. So this is why most of the people do not go there unless they are facing some issue. But for cardiac diseases, the issue is that when the symptoms are appearing, there has been enough amount of blockage in the artery already. So for early diagnosis or for early sensing of these disorders, it is very important that we find out some method which could promote the low cost and easy detection. There are also a few techniques which are providing the qualitative testing, which are low in cost, but they are again, like you can see in the lower table, that their detection limit is usually very low, and it cannot cover very wide range of the cardiac troponin I levels present in blood. So the next we are looking at the problem at hand. So we have traditional methods. The drawbacks are they are time taking, expensive, etc. And what we need is a point of care biosensing device which has good sensitivity, reproducibility, and specificity. So this is a brief introduction about biosensors, that we have a bioreceptor, transducer, and signal processing processor, which actually takes up the amount of the biomolecule available, and then it provides us a signal which can be readable through us. And this is a brief introduction about electrochemical sensors. They basically, what they do is they take the biomolecule concentration and convert it into some electrochemical signal like current or potential, etc. The path we have followed here is, first of all, we have worked on an in-house designing of electrode and their printing using screen printers. So first we are designing in-house electrodes using high efficiency designing tools. Then we are printing the electrodes using screen printing. Then we are functionalizing the electrode using our bioreceptors and biorecognition elements. And then we are using this entire platform with a electronic device to measure the cardiac biomarker present in the sample. First of all, how we are designing on the lower image, you can see that there are different types of designs available. That this is how we are designing the electrodes, and then on the using the screen and conductive ink and substrates, we are able to print the screen printed electrodes. You can see the completely ready electrodes in the image. Next, we will take this electrode and then we will functionalize the electrode using an amine functionalization, which will provide us the amine group which will be used for binding with antibodies. When the antibodies are which are specific to our antigen or an analyte is introduced into the system, this antibody will be used and for the detection of the amount of the analyte present, which will be directly proportional. We have characterized the platforms that we have prepared after the biorecognition element functionalization. We have done different kind of characterization techniques like AFM, zeta potential, and we have other techniques also. But here I will show you that in the AFM graph, you can see that there is a subsequent increase in the size, which depicts that when we are introducing some functionalization agent, it is able to patch on the surface that we are providing here. Like first the lysine, which is used for amine functionalization, then the protein A, which is used for antibody aligner, and subsequently the steps are done. And the other thing, table you can see here is for zeta potential. It is depicting the change in the charge of the system, which is aligning with the electrochemical characterization we have performed for our multiple steps. Next, we have the device performance. When we have prepared the electrode platform, then we have joined this platform, the biologically functionalized platform, with the electronic device. On the top left A graph, you can see that we have used multimeters and different other devices for measuring the resistance, since the signal which is produced here is due to the increase in resistance because of binding of analyte. On the right side, you can see that we have used a standard CH instrument graph and the CSIO readout. We can see that the CSIO readout gives us a better linearity as compared to the CH instrument graphs. And then we have performed different parameters like the incubation time from 10 to 15 minutes or the run time, etc. And we have used multiple electrodes. On the D graph, you can see that we have compared the data from multiple electrodes, and then summarize the F graph, which is the cardiac troponin concentration variation with respect to the analyte increase. The uniqueness of this troponin device is that, first of all, it is a very low cost chip, and it's a low cost readout. So this will enable us to promote people more for an early test or detection, like when they are not exhibiting the symptoms, they can measure very small quantities from 5 picogram per ml to 200 nanogram per ml, and this is how we can provide an early diagnosis for cardiac arrest. Secondly, it's a very fast and quantitative. The time taken in this is only 5 minutes. It is very easy to use and portable, and this is how this is why it can be sent to the remote areas or the point of care centers, point of care workers, officials, and even to the rural areas where these Anganwadi or these healthcare officials can easily operate them. It does not require any sophisticated instrument or any high skilled labor. And then it is an open-ended platform, and the device and the electrode can be used for any other disorders, and then they can perform the diagnosis of other diseases also. So this is a small video to show the performance of the device. So you can see here that how the sample was added, and the value of the current or the parameters was displayed on the screen, and this is how we can calculate the amount of analyte present in the sample. Now, the innovation impact is that first of all, it has high impact on economic conditions. Like I said, it can go to the very small areas where because of it being very low cost, it will help us through the early detection in rural areas or remote areas. This sensing will also provide early diagnosis, which will reduce the healthcare cost. It will promote the economy because everything that is used in this is produced in indigenously, and it will promote platforms like Make in India, etc. The social impacts are obviously the loss of life will be comparatively reduced if we are able to early diagnose. It is very easy to operate, so anybody, even household individuals, regular people can operate it. And then the early diagnosis will obviously enable us all to create more awareness about these kind of disorders. This is our team here at CSIO. I thank for CSR for the funding, and we have already filed the patent for this. Thank you so much. Is there any question?
Yeah, thank you, Neelam. Any questions from the panelists?
Thank you, Neelam. Thank you for this very interesting piece of work. And actually, it is a very important piece of work because nowadays we see that, especially in this COVID timings, the people who are having comorbidities, they are suffering more. So it is very important that one can diagnose the problem in its very early stages so that it can be treated very soon. And as I wanted to mention for Dr. Rasheed Patel also, that the cost, especially in a country like ours, the cost of the product is very important. So both of you have developed products which are very low cost so that the common man is benefited. So this is what exactly the objective of this webinar was, that this is for the technology for the society, and this technology, when it is coming from our female friends, it gives a very great deal of satisfaction. So thank you so much, Neelam, for this wonderful piece of work.
Thank you, ma'am. Thank you so much.
Yeah, thank you, Dr. Nishima. Next, moving ahead with the next speaker, Anshul Liti. She is a PhD student from Department of Biosensors and Biomedical Engineering from IIT Indore. She has cleared her JRF and GATE. She is also a member of Algal Ecotechnology and Sustainability Group. Her broad research areas are development of microalgae-based therapeutic solutions. Yeah, Anshul?
Thank you so much, ma'am, for the kind introduction. Hello, everyone. I am a first-year student at IIT Indore, and I would like to thank the organizers for giving me this opportunity. Shall I share my screen?
Yes, yes, please.
Yes.
Ma'am, is my presentation visible to you?
Yes, yes, it's visible.
Okay. Hello, everyone. Welcome everyone to my presentation on innovative wastewater treatment technologies, today going to tomorrow. So from the 37 crore population at the time of independence, we have now reached to 120 crore population now. Back then, we were majorly a rural economy, and now we have 37% of our economy is urban, and it is still growing fast. So this stresses, this transformation of our society puts a huge stress on our resources, and we have come to a situation where we are pumping out approximately 38,000 million liters of untreated waste sewage into nature, and which poses a great threat to our health and ecosystem. Through my presentation, I hope that I'll be able to put across the point that wastewater can be a valuable resource, and it can generate huge environmental and economical benefits. So my point is, it is too valuable to waste. So in my presentation, I have the following contents. I'll first introduce you to the major water pollution, how it impacts us. Then I will talk about various wastewater treatment technologies. Then we will further discuss different examples from around the globe of wastewater treatment. And then I will show you how microalgae can help us in degradation of pollutants, and especially I'll focus on how dye pollution can be tackled through microalgae. And then finally we will conclude our presentation. So firstly, I would like to spend a little bit of time to introduce you to how water pollution impacts us. The problem of water pollution is largely remain unseen to us. We don't pay much attention. If we have a drinking water problem at our home, all of our family members, including our neighbors, will know that we have a problem. But what happens to our sewage? Does it get treated? Then that we don't care much. As a society, we don't pay much attention until the time we know that 21% of the diseases that we face today are waterborne diseases. The contaminated water can cause deadly diseases like cholera and typhoid. I want to highlight some statistics that according to World Wildlife Fund, 17% of global population and 10% of the world GDP is currently under high water risk. According to World Bank, 80% of India's population depend on groundwater for drinking drinking and irrigation. And unfortunately, according to one CPCB report, only 37% of the wastewater is treated in India, and the rest is going back into our ecosystem. And not only on the human health, the wastewater has direct impact on the marine life as well. In 2010, a deep horizon spill in the Gulf of Mexico, it killed many millions of marine animals. So unfortunately, in this situation we are now, the only solution is treatment of this wastewater into and wastewater recycling. So treating that is converting the sewage into water that can be reused for a variety of purposes. Internationally also, the United Nations General Assembly is putting greater focus on the water, and they have launched a water action decade from 2018 to 28 in order to achieve our goals of 2030 sustainable development goal of clean water and sanitation. So coming on to the different technologies that are used for wastewater treatment, they can be classified into physical, chemical, and biological. The physical being the membrane separation, adsorption; chemical being the chemical oxidation, photooxidation; biological, biodegradation technology. So despite all these, I want to focus that despite all these advancement in our technologies, what is the major question? The major question is that are we able to pay for these technologies? Our local bodies, they are not being able to treat our sewage, and they are not able to sustain the sewage treatment plant. They have their resources are limited. So that's the major constraint. Let's take a look at some of the examples from different countries where they have successfully treated their sewage along with the production of electricity and other methods. So one example is Malta. It's a small island country in the Mediterranean Sea. They have installed a sewage treatment plant which can convert all of the sewage of the country, and it can generate enough power to power the 1400 houses in the entire country. And other examples are in Australia, the capital city of Adelaide. They have installed a desalination plant. Australia faces droughts every year, and they have tackled this problem through installment of these plants. Another example is Israel, which is a world leader in wastewater treatment. 80% of the sewage that the country generates is treated, and natural filtration quality of sand is used in a Dan region wastewater treatment plant to improve the quality of sewage treatment in this country. So despite all these examples, the major point is that managing the wastewater is highly expensive, and in many countries the cost of the reclaimed water exceeds the cost of the water that is available naturally, and that includes India as well. So we need to find a sustainable solution. We need to find a solution that is economical, and that is why we need to turn our attention to microalgae. Microalgae are photosynthetic organisms. They, compared to the terrestrial plant, they can convert carbon dioxide and solar energy into various bioenergy forms. The major advantage of microalgae for the treatment of wastewater is that they not only generate the reusable wastewater, but also they can produce microalgal biomass, which I'll show further. That microalgal biomass has many applications, and the microalgae can be grown in open pond like structure, and they can be used for, they are currently being used for wastewater treatment plants. Now I will show you the various mechanisms through which algal cells can degrade the pollutants. On the microalgal cell, there are various biomolecule proteins and carbohydrates that interact with the pollutants in the wastewater, and through electrostatic attractions, ion exchange, and physical adsorption, they get absorbed on the surface of the algal cell, and that's how they get removed through the algal biomass. The other mechanism is bioaccumulation, in which the pollutant is absorbed inside the microalgal cells in the form of vacuoles. Other mechanisms are through enzymes, through intracellular and extracellular enzymes. The enzymes can degrade the harmful pollutants into less harmful products intracellularly or extracellularly. So one of the pollutants is dyes. Dyes are produced majorly from the textile industry. They are highly extremely toxic, and they can be carcinogenic. The currently available methods for dye degradation, such as coagulation and adsorption, they are not they have a major drawback that they are not cost effective, and they produce a large amount of sludge, and they can cause further pollution. And in our lab, we have tested a microalgae called Scandesma species, and for its ability to degrade the Congo red dye. And what we did was we grew the algal cells along with the Congo red dye and at various concentrations. And after the growing conditions, after 20 days, we checked the level of this dye, and we found that in the preliminary results, we found that almost 80% of the dye got degraded through this Scandesma species. And this gave us opportunity that we can identify more microalgal species for identification of species which can degrade the dye in better manner or other pollutants. So like that, in other members of our lab are working on microalgal based applications which is grown in the wastewater. And I want to highlight that the microalgal based wastewater treatment not only generates the reusable wastewater but also has various applications such as biofuel production, biodiesel production, biohydrogen production, pharmaceutical, bioplastics, like that. So I want to point out that we need to look at our wastewater not as a burden but as a resource. We need to realize that the potential of wastewater we need to realize the potential of wastewater and shift our focus from the wastewater treatment to wastewater resource recovery. In conclusion, we have found that the Scandesma species has a potential to degrade the harmful Congo red dye, and we are further testing other algal species for dye removal. Algal are important phytoremediation agents, and major point is that algae not only help in water remediation, but they have a much wider scope of other applications. And in our lab, the research is ongoing on various applications of microalgae, such as bioplastic production, nanoparticle biosynthesis, carbon dioxide sequestration, and lipid production. So we are working tirelessly. We are committed to convert this narrative from wastewater being a burden to a resource which can benefit our society. I would like to acknowledge Finally, I would like to acknowledge my guide, Dr. Kiran Bala, for her guidance. I would like to acknowledge my lab members for their support, and UGC for providing me fellowship, and the Department of Biosensors and Biomedical Engineering and IIT Indore for providing the facilities and infrastructure. On that note, thank you very much for your attention. Have a good day. Thank you.
Thank you, Anshul. Again, your project or your research is wonderful towards providing water to everyone. In fact, you are using wastewater and treating it. So that is an additional activity which makes it possible to have polluted water also for use. So any questions from panelists?
If there are any questions from the other speakers also, they can also ask
Yes,
if they have any queries.
Anshul,
there are no questions, I think, Dr. Suman. We can proceed ahead.
I have just one question. Anshul, have you characterized or have you studied the quality of your water before and after treatment?
Anshul, you are muted. Please switch on your microphone.
Yes, ma'am. This is a preliminary data, and we are working further. I'm not sure we have done.
Okay, I think you are the first year student, so okay.
Yes, ma'am.
Fine, good. Thank you.
Anshul, you can also stop sharing the screen. Yeah, thank you.
Thank you. We have reached to the end of this event, and thank you all the speakers for sharing your technologies. We wanted to hear you more participation, but it was very interesting sessions. Thank you all the speakers. Now, any feedback from the panelists or any questions regarding the topics they have covered?
Yeah, please feel free to express if you have any feedback.
But Nagar ma'am, welcome.
Good afternoon. We started in the morning and now it's afternoon. Wonderful session, and in spite of me shunting in and out of the room, the volume of the system I had kept high because each and every presentation was so good and very much in line with the theme of this year's celebration. And I'm very, very happy to note that Dr. Nishima, Dr. Suman, our young scientists have put up such a great show. So I have been given this lovely duty of putting forth the vote of thanks. So I'll start by thanking our Honorable Vice Chancellor for giving us this boost to carry on with our activity of Women in Science in collaboration with INYAS. And then I would like to thank Professor Kea. What a lovely insight into the entire topic. You know, I wish every woman, every girl child understands this. You know, it was coming from within, ma'am. And for legends like you and Professor Grover being on the panel, it was so good. We thank you, ma'am, for this lovely presentation and the way you put the whole thought ahead of us. And Professor Grover, has he left the meeting?
Yes.
Yeah, we would like
yes,
to thank him. And we know that an academician that he is a big supporter of all of us here, the women and the girls. So we thank you, Professor Grover. We'll send the message across to you in another form. And we would like to thank our chair, Dr. Chandrasekhar Sharma. Is Dr. Sharma around? No. I mean, it's quite late now. And so we are a small group here in the Punjab University. So Professor Deepti Gupta, then we have Professor Jagdeep, Dr. Suman, Dr. Pavitra, so many others. I wish to thank each one of you for your timely help and suggestion from various quarters that you have been extending to all of us. And we have our young designer Meghna from university who has designed the lovely flyer. And Meghna, I'm going to catch hold of you for more flyers now. So beware. And
in huge demand.
She's in huge demand, ma'am.
yes, I'm sure she must be. And I would like to say this to each one of you here that yes, we have to work towards the sustainable goals, and all the presentations spoke so. And yes, we should thank the presenters, all those who expressed their experiments and their efforts in this direction. A big clap for all of them, really. And I wish all of us take this message personally. You know, for example, I'd just like to cite a small example. So my children's nanny, who has her daughter who was in class 12. So I was guiding her, I was helping her. Of course, she did all the efforts by herself. So she cleared the NEET exam. Now she doesn't know how to, go in for counseling. So do this hand holding for girls around you. Encourage to become something. The parents are illiterate in my case, and this girl is getting awards in calligraphy, in oral, efforts of oral speech. So just a little bit of hand holding, and you can carry with you at least a dozen girls in this lifetime to a level which their parents would not have even dreamt of. So as I say this, I am getting goosebumps, and I want each one of you to take this message and handhold at least one girl child to begin with, and do it in any possible way that you can. I'm not saying that you have to do big things. You have to start with a small effort, which matures into a lovely one. So in my case, I feel so nice when I look at this girl called Suman again. And I wish all of you great success. May you all rise and shine in coming times, and we will celebrate this event every year with greater zeal and zest. So thank you, Dr. Nishima, and thank you, Dr. Suman, for carrying out the entire event. Thank you, ma'am. We are always in awe of you.
Thank you. Thank you for having me here. It was a
Yeah.
very nice session to watch all these young girls,
Yes.
and they have done it with so much of zeal, so much of enthusiasm. It's really good.
Yes.
Thank you, ma'am, for taking out time. Actually, Kia, ma'am, thank you so much. Thank you. Your words are still ringing in our eyes, and thank you so much, Archana, ma'am. And you gave us a perfect example to end this whole session with your example of Suman. And thank you, Suman, ma'am, also for handling this today. And thank you, Neelam. Thank you, Rajshri and Anshul and Poonam and Deepika also for your wonderful presentations. Thank you so much. Thank you, everyone.
Photograph, Nishima?
Yes, of course. Please, if you can switch on your cameras, Neelam, Rajshri, Poonam, Deepika, Anshul. Anshul, Deepika, yeah. Please switch on your cameras.
Anshul, are you going? Anyways.
Anshul, if you can switch on your camera. Okay, we can click it now. Yeah, thank you, Anshul.
Thank you.
Thank you, everyone. Thank you. Have a nice day. Thank you for celebrating February 11 with us. Thank you all.
Thank you, ma'am.
Thank you, everyone.